Hello guys, welcome back to our channel where today we are to consider equation in continuous random variable. Let's consider equation which most of us take to be complicated, but in real sense you're gonna like it as one of the simplest. The equation reads, the time x in hours between computer failures is a continuous random variable with a PDF lambda exponential of negative 0.01x for x greater than 0 and 0 elsewhere. We are told to find lambda, hence compute probability that x is greater or equals to 50 and x is less than 150, and the probability that x is less than 100. The solution is, we know that for x greater than or equals to 0 and the integral of f of x from negative infinity to infinity of f of x is equals to 1. Therefore, to find lambda, we are going to integrate from 0 to infinity because our limits are greater than 0. Of our equation, that is lambda x negative 0.01x is equals to 1. We are to factor out lambda since it is a constant. We say lambda integral of from 0 to infinity of exponential negative 0.01x is equals to 1. Now we do the integration. We know very well that the integral of exponential power ax is equals to 1 over a eax. Therefore, our integration will be lambda brackets, then we will be having, this one will be 1 over 0.01, but negative because of the negative up there, exponential of 0.01x, also negative, is equals to 1. Then we substitute the limits from 0 to infinity. Before substituting the limits, we now will be having negative 1 over 0.01 lambda into exponential of negative 0.01x. Then we substitute the limits from 0 to infinity should be equals to 1. This one is the same as negative 100 lambda into exponential of negative 0.01x. Then we substitute the limits to infinity is equals to 1. We substitute the limits by saying negative 100 lambda. If we substitute the limit on our calculator, exponential of infinity, then we substitute there, we get exponential of infinity minus exponential of 0 is equals to 1. The exponent of infinity to our equation will have the exponent of infinity is 0, then the next exponent of 0 is 1 is equals to 1. Now we'll have negative 100 lambda into negative 1 is equals to 1. If we multiply out, we get 100 lambda is equivalent to 1. We divide both sides by 100, we divide both sides by 100. Our lambda will be equals to 0.01. By solving for lambda, we shall have answered part 1 of the equation. Now part 2, we are told to find the probability that x is greater or less than 50 and x is less than 150. Here we are to integrate from 50 to 150 our function. With function, we had f of x is equivalent to 0.01, which is the value of lambda exponential of negative 0.01x for x greater than 0 and 0 elsewhere. Now we are just to integrate our function, that is the integral from 50 to 150 of 0.01 exponential of negative 0.01x. This will be equals to, we factor out the constant, that is 0.01, integral from 50 to 150 exponential of negative 0.01x. Now to integrate the exponent, we know that the integral of exponent of x will be equals to 1 over a exponent ax. Therefore, we'll be having 0.01 in the bracket. This one will be 1 over 0.01 negative exponent of 0.01x. Then we substitute the limits from 50 to 150. From here, now we'll be having this one with 0.01. We multiply, we bring this one outside, itakuwa negative. This one is negative 100 into the exponent of negative 0.01 multiplied by the upper limit, that is 150, minus the exponent of negative 0.01 multiplied by the lower limit, that is 50. This one here will give us 1 into exponent of negative 1.5 minus exponent of 0.5 negative. If you press your calculator, give 1 into exponential of negative 1.5 minus exponential 0.5. We press this in our calculator and we have the answer as 0.3834005, and this one is our answer for part 1. Then part 2, they say probability that x is less than 100. We do the same thing. We will integrate from 0 to 100 for our equation 0.01 exponential of negative 0.01x. Because we've done everything, now we can just come and replace, because we know the integration there. Now this one will just be 0.01. Then we open the brackets. We have 1 over negative 0.01, the exponential of 0.01x. Then we substitute the limits from 0 to 100. From here, we again take this one outside. We will be having 0.01 multiplied by negative 100. Then we will be having exponential of 0.01. Our x is 100. We substitute there, minus exponent of negative 0.01. Our exponent there is 0. Then we substitute the limits. Here we will be having negative 1 into the exponent. If you substitute this one, we get exponent of 1 minus the exponent of 0. If you calculate this one, you find your answer as 0.6321206. Thank you for viewing. Like and comment and subscribe if you had not. Thank you very much. Till next time.